Hey guys, how you doing? It's Coach Scott, and hey, we're going to start our new unit, and this is on chemical reactions. And I think we're going to have a lot of fun with that. We've actually been through some of our hardest math we have to worry about with stoichiometry, and y'all got through it. We pushed through it. We got an understanding. We're going to build on that with our chemical reactions. So before we get into an actual reaction, let's talk about what physical and chemical change is. And we might change some of our definitions of what these things are. Okay, so a physical or a chemical change, right? So what have we learned so far? We've learned that all matter is made up of atoms. And oftentimes these atoms will combine these with other atoms in a specific way. So the single atoms, or the combination of atoms, are called particles. So we're going to talk about two types of changes, okay, that we're going to be looking at. We're going to be looking at physical change and chemical change. Now, physical change does not change what the particles are. All right. The only thing it changes is, whoops, wrong thing. The only thing it changes is how they're arranged, okay? Are they together or not, okay? Now, the chemical change does change what the particles are, because so they will rearrange these atoms and become a different particle or a different substance. Now, we're not affecting the atoms themselves. We're just affecting these substances, right? The atoms are still atoms. Okay. So, usually, I said usually, physical changes are considered to be reversible by physical means. All right. We can also say that physical changes are easily reversed. That's not true, but it's possible. Okay. Now, as we've discussed before, as we discuss some of these examples, you'll see some changes which are considered to be physical changes, and you can decide if it's easy to go to the reverse direction or not. Now, changes of state, we've talked about those when we were going over intermolecular forces. Changes of state are usually easier to reverse by just changing the temperature or the pressure. All right. The particles are unchanged by the process. Now, let's think about water. Okay. Water will undergo all these changes, and they're still going to end back up at the first stage. The particle, H2O, does not change just how they are arranged. We talked about melting. We talked about freezing, vaporization, condensation, sublimation, or deposition. Those are changes of state. So, for instance, ice will melt. Then it's going to boil. You take some heat away, then it's going to condense back to a liquid. Then eventually it will freeze. The water's still water. It just changed state. So, with the right conditions, the water can go back to how it started. The particles, the H2O, don't change regardless of the state of matter. It's still H2O. It's just whether it's in the solid state, the liquid state, or the gaseous state. Now, let's think about broken glass. It's not as easy to unbreak that glass, but it is possible to melt it down and reform it. So it's possible. The particles that comprise the glass are unchanged, all right, when the glass is broken. So, when we cut or shred paper or any other material, that's a physical change. It's pretty difficult to reverse, but it's theoretically possible. It's the same thing if we cut wood or tear a cloth or crush a can. Those are physical changes. The particles in the material, they're unchanged, but the state has changed. Now, if we dissolve a solid in a liquid, that's a physical change. Okay? let's use it for instance. When we dissolve sugar or salt in water, now when we evaporate or collect the liquid and solid can be separated. The particles that comprise the liquid or the solid are not changed in the process. So when we mix oil or water, we're creating a mixture. So a mixture is a physical change. Now we can undo this by separating them again. So if we mix sand and water, well, we can decant the water, pour it off. We can filter out the sand. Or a mixture of salt and pepper. We can separate those pieces. It might take a while. It may not be easy, but we can separate salt and pepper. When we mix a substance together, that's a physical change. The substances don't change, only how close they are to other substances. Even when I make a cake, that is a physical change. Or when I mix up a cake, now when I make a cake, it can be a challenge, but we can still, the particles aren't changed as I mix all those materials up. We can, with different methods, separate them back out again. But when I put the cake batter in the oven, and turn on the heat, then the chemical change occurs. The ingredients react together so that the new particles form from the atoms that make up the original particles in the ingredients. Okay, they can't be separated back to their original form by any physical means. That's a chemical change. When I burn a stick, that is a chemical change. The particles in the wood and the air react to form a new combination of atoms. This creates new particles from the original particles. So once the wood is burned, it's not possible to recreate the ash and the gases which remain. New particles have replaced the old particles, both being combinations of the same atoms. So when I grow animals or plants or trees, when they take nutrients in or particles, they change them so they can grow. So living things, they'll take in air, food, nutrients, and they'll grow. The particles that comprise those things that go to life are broken down, and their atoms are rearranged into new combinations. These new particles that comprise the living organism. A physical process cannot recover all those particles back to their original form. So, to understand chemical change, we've got to look inside atoms to understand how they are constructed. And that's what we've done already in this course. Then we can learn how atoms combine to form different particles. And then we can recombine to form the new particles during the chemical process. That's what a chemical reaction is. Rearranging of the atoms to form a new arrangement or a new substance. Okay, so we'll be talking about this in class. This is Coach Scott saying thank you guys for all you do, and we'll be talking to you later. Have a good day.